Class 15, we're going to start a topic called transformations. So let's go over the preview exercises together. We want to graph f of x equals the absolute value of x using the following ordered pairs. So -3, f of -3. So f of -3 means take -3 and plug it into your formula. And the absolute value of -3 is 3. So my points are actually -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. So for each x value, I'm taking the absolute value and getting the y value. Alright, so if I plot these, -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. Connect my points. Good. All right, so now for step 2, I want to subtract 4 from each y coordinate from the ordered pairs we got in number 1. And I want to graph those. So I'm going to switch colors and subtract 4 from each y coordinate. So my new points, my x values are going to stay the same, but then my y value is going to be my old y value minus 4. So 3 minus 4 is -1. 2 minus 4 is -2. 1 minus 4 is -3. 0 minus 4 is -4. 1 minus 4 is -3. 2 minus 4 is -2. And 3 minus 4 is -1. So notice that nothing changed with any of my x coordinates, right? This list of x's and this list of x's are exactly the same. All they told me to change was the y coordinate. Subtract 4 from the y coordinate. So I'm going to plot these new points, -3, -1, -2, -2, -1, -3, 0, -4, 1, -3, 2, -2, and 3, -1. And I connect those points. And it appears that my orange graph looks exactly like the green graph, except I shifted the whole thing down 4 units. Okay, so the graph for number 2, that's my orange graph, is the green graph. It looks exactly like the green, but shifted down 4 units. Okay, and that kind of makes sense because I was subtracting 4, so it makes sense that it would move down from the y coordinates, and y coordinates represent vertical movement, right? So I moved the whole thing down 4 by subtracting 4 from the y's. Okay, I'm going to leave number 4 for you to do on your own. All right, never mind, I'm going to do it with you. Okay, so I want to graph f of x equals x squared using these ordered pairs and connect them with a smooth curve. So my points are actually going to be -3, comma, and then I have to take that -3, the x coordinate, and plug it into f. And f is the function that is squaring things. F of x is x squared. -3 squared is 9. So I have -3, 9. Then I have -2, comma, -2 squared, which is 4. Then -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. So I plot them. -3, 9. -2, 4. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Connect them with a nice smooth curve. Alright, so that is the graph of y equals x squared, or f of x equals x squared. Now I want to add 2 to each x coordinate of the ordered pairs that I just found. And I'm going to graph the new curve. So my y coordinates are all going to stay the same. I'm going to have 9, 4, 1, 0, 1, 4, and 9 as y coordinates. Those stay the same. The only thing I'm changing is I'm going to add 2 to each x coordinate. So -3 plus 2 is -1. -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. And 3 plus 2 is 5. So I just took all my old x coordinates, added 2, and now I'm going to plot these new points. -1, 9. 0, 4. 1, 1. 2, 0. 3, 1. 4, 4. And 5, 9. Connect them with a nice smooth curve. And I want to describe the relationship between the orange graph and the green graph. So they look almost identical. It's just that the green graph looks just like the orange graph, but I shifted the whole thing to the right 2 units. So my green graph is the same as the orange, shifted right 2 units. And it makes sense that I moved this thing horizontally because I was adding to the x coordinate, and x is measuring a horizontal location. So when you add or subtract from the x coordinate, you're going to move your graph left and right. So moving on to the demo, we want to graph f of x equals x squared by hand, which we actually just did in the preview exercise. So I can do that pretty quickly. -3, 9. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. 3, 9. And then I have a little bit more room that I could do 4, 16. And -4, 16. Because 4 squared and -4 squared both give you 16. All right, so we connect those with a nice smooth curve. All right, so step 2 is to use a calculator, a graphing calculator or GeoGebra, to graph each of the following functions and graph them in a different color. Copy their graphs onto this paper. All right, so using a graphing calculator or GeoGebra, or your intuition from what we looked at in the preview exercises, let's think about g of x. I want to graph x squared plus 3. So my y value is going to take whatever my x value is and square it and then add 3. So it's pretty similar to just squaring it, except that you have to add 3 to every y value. So this whole graph is going to get shifted up 3 units. So every point on this graph is going to move up 3. So -3, 9 is going to become -3, 12. Move it up 3 units. -2, 4 becomes -2, 7. -1, 1 becomes -1, 4. 0, 0 becomes 0, 3. 1, 1 becomes 1, 4. 2, 4 becomes 2, 7. And 3, 9 becomes 3, 12. And I'm not going to do the last one because moving it up 3 would take me out of the grid. So I can just graph this in orange here. So that's a G. The green one was my original, which is F. All right, and then I'm going to graph H, which is going to move, it's going to take my original graph of F, the green one, and I'm subtracting 4 from the x squared, which means I'm going to move the whole graph down 4 units. So every point on the graph of F is going to move down 4 units because I'm subtracting 4 from what the old y value used to be. So instead of 0, 0, I'm going to have 0, negative 4. Instead of 1, 1, I'm going to have 1, negative 3. And instead of 2, 4, I'm going to have 2, 0. And instead of 3, 9, I'm going to have 3, 5, because I'm subtracting 4 from the y-coordinate. Instead of 4, 16, I'm going to have 4, 11. And then the other half of the graph is symmetric. So I can just copy the heights of these other points. And connect those. And there is the graph of H. So in your own words, we want to describe what happens to the original graph of F to get each of the new graphs. Has the graph been moved left, right, horizontally, or up and down, which is vertically? So G was F shifted up, and H is F shifted down. So to get the graph of G of X, the graph of F of X moved, shifted up 3 units. And to get the graph of H, the graph of F of X was shifted down 4 units. All right, so I just want to verify what we discovered here by evaluating f of 0, g of 0, and h of 0 and see what we see. Okay, so f of 0, remember f of x was just x squared, so if you plug a 0 into x squared, 0 squared is 0. G of 0, well here's my formula for g. If I put a 0 in there for x, 0 squared plus 3 is 3. And h of x is x squared minus 4. If I put a 0 in for x, I get 0 squared minus 4, which is negative 4. So you can see this relationship of adding 3 also meaning moving up 3, and subtracting 4 meaning moving down 4. And then one more, f of negative 2, that means negative 2 squared, which is 4. G of negative 2, you go over to your G graph again. Put a negative 2 in there. Negative 2 squared is 4, plus 3 is 7. And then h of negative 2, put a negative 2 in there and you get 0. So again, that relationship holds. The y value for all of these three graphs have the same x value. All of these 3 points I just looked at, the same x value of negative 2. F is 4. Oh, I messed up with G. Right, G of negative 2. Negative 2 squared is 4, plus 3 is 7. There we go. All right, so to get from F to G, you added 3. And that's why there's that plus 3 there in the formula. To get from F to H, we had to subtract 4, and that's why there's that minus 4 there in the formula. All right, let's look at the domain and range of f, g, and h. So f of x, let's just jot these down so we have them written, is x squared, and g of x is x squared plus 3, and h of x is x squared minus 4. All right, so the domain of f. What values of x can you plug into x squared? Anything. You can square anything. So my domain of f is negative infinity to infinity. And then the range is the smallest y value to the biggest y value. And the smallest y value on the graph of x squared is 0. And then it just goes up from there. Right, because f of x equals x squared looks like this. So smallest y value is 0 and it gets bigger. The domain for g and h are the same, right? If you can square anything, then you could square anything and add 3 or subtract 4. So my domain is negative infinity to infinity. on both of these. But the range of G, right, if you look at the graph of G on the previous page, the smallest y value for G, okay, I could just do a quick sketch. X squared plus 3 was like this. The lowest y value there, that's 3, and then it goes up from there. So this is 3 to infinity. And for h, the lowest y value was -4. So it goes from -4 to infinity. So has the transformation changed the domain at all? No. Domains are all the same. Has it changed the range? Yes. Right? My ranges are different. And it makes sense that my ranges are different because I was changing the graph by adding or subtracting from the y value. Okay, so my range, which is the set of all y values, would probably change. All right, I want to rewrite G and H as a transformation of F. So instead of x squared plus 3, I want to write this in terms of F. So remember that f of x equals x squared. So wherever I see an x squared, I could replace it with an f of x. And that's what I'm going to do here. Instead of x squared plus 3, I'm going to write this as f of x plus 3. And h of x, which was x squared minus 4, I'm going to rewrite that as f of x minus 4. Doing this rewriting can help you identify what transformation is happening as we move through more and more kinds of transformations. So I want to apply the transformation to a few points on F to find the corresponding points on the transformed function G. So -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, these are all points on the graph of F. And my graph of G, which is f of x plus 3, that means add 3 to every y value, because f of x is just a fancy name for y. So if I'm doing f of x plus 3, that means y plus 3. Add 3 to every y value. So my corresponding points on G after the transformation are going to be -2, 7, -1, 4, 0, 3, 1, 4, and 2, 7. So notice that the x coordinates didn't change at all, kept the x coordinates exactly the same, and I just added 3 to each y value. I'm going to have you start working through the class activities. You do have the answers. Class 16 has no demo, so I just want to be clear there. Class 16 has no demo. It's just a continuation of the class activities from this class. So you're going to work through both of those, and then in class 17 we'll do a little summarizing.